Okay, we're going to talk about some trig identities. Okay, first of all, let's talk about reciprocal identities. Let me try to zoom in a little bit here. Right, basically some of the things we know. All right, cosecant of theta is 1 over sine of theta. Secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. Okay? All right? They're reciprocals of each other. Right? Equivalent forms of these reciprocal identities, basically, it just helps to know sometimes. You'll see when we're solving problems, we're going to have to rewrite these equations, just like we do with polynomials and rational functions, to rewrite equations so things can cancel out. Sometimes you might see 1 over cosecant theta, and you need to know that's sine of theta, right? Sine of theta, and cosecant are reciprocals, okay? Just like cosecant is 1 over sine of theta is 1 over cosecant of theta. Cosine is 1 over secant of theta, okay? And tangent is 1 over cotangent. Okay, so these all go together, obviously. They're all reciprocals of each other. But it's important to know that, hey, you might be able to rewrite this 1 over cotangent as tangent. Okay? All right. Here's some ratio. So those are kind of what we call reciprocal identities. Here's our ratio identities that we should be pretty familiar with. We know from SOHCAHTOA, right? Here's theta, that cosine is adjacent over hypotenuse, x over r, right? Sine is opposite over hypotenuse, y over r. Okay, tangent is opposite over adjacent, which is y over x. Okay, but let's go back. Tangent of theta, I've been telling you now, start thinking of it as sine of theta over cosine of theta. Right? Remember, sine of theta is what? Y over r. Cosine of theta is x over r. Notice how those r's will cancel out, and that's how we get y over x, opposite over adjacent, okay? So we just have to have a lot of different ways to write things, okay? So we know tangent of theta is sine over cosine. That means cosine, same thing, is going to be reciprocal. Since they're reciprocals, it's going to be cosine theta over sine of theta. X over r over y over r, the r's cancel, and cotangent's x over y, okay, if we're on the unit circle, okay? All right, so tangent, sine over cosine, cotangent, cosine over sine, all right? I've kind of explained to you, when we square sine, we kind of write it like this, with the square over the sine, we leave theta alone. But sine theta squared would be right, sine squared theta. Okay? All right, moving on. Most of you, except for one class I didn't do this for, so I'm doing this for everybody again. Remember, cosine of theta, x over r. Okay? So if I want to solve for x, I multiply both sides by r. So x is r cosine theta. That's x. I multiply both sides by r for sine theta is y over r. So y equals r sine theta. Okay? All right. So now we're going to get into what we call our Pythagorean identities. And we know this is a right triangle here. And we know that x squared plus y squared equals r squared. A squared plus b squared equals your hypotenuse c squared. In this case, like I said, it's x squared plus y squared equals r squared. Well, what is x? X is, we said, r cosine theta. Okay, so we're going to square x. Y is r sine theta. We're going to square that. Okay, so r cosine theta squared plus r sine theta squared equals r squared. That is your a squared plus b squared equals c squared. Your x squared plus y squared equals r squared. Okay, so here I went ahead and squared everything. R squared cosine squared theta plus r squared sine squared theta equals r squared. Notice because I squared everything in the parentheses. Well, r is 1 on the unit circle, right? So r squared is just 1, and it goes away. R squared is 1, and r squared is 1. Okay, so that leaves us to our first trig identity, where cosine squared theta plus sine squared theta equals 1. That's 1, 1, and 1, okay? So that's a major identity, and you can manipulate this as you need to sometimes, okay? Cosine squared theta plus sine squared theta equals 1. And I don't care what your angle is, it's going to work out, okay? Here's some equivalents. Equivalent forms. Let me zoom in just a little here for that, okay? Notice what cosine, okay? If I want to get cosine by itself, I'll subtract sine squared from both sides and get 1 minus sine squared. So cosine theta would be that 1 minus sine squared theta, but square rooted, right? We square rooted both sides. Okay, if I wanted to solve for sine, I'd subtract cosine squared from both sides to solve and get sine by itself. And you square root both sides. Sine theta equals the square root of 1 minus cosine squared theta. Okay, you never know. You might need to, you might see something like this, and you might need to recognize it as sine of theta. Okay, you might see this, and you might have to resubstitute cosine theta. All right. I've got some more Pythagorean identities here. 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. These are your 3 Pythagorean identities, okay? At least I have for you right now, but that should be it for a while, okay? Let's talk about how we get the second. Okay? Here's my cosine squared theta plus sine squared theta equals 1. Let's just, for grins, divide both sides by cosine squared theta. Okay? So now I'm going to rewrite this as cosine squared theta over cosine squared theta. Notice how I just rewrote this fraction. The denominator is what? Cosine squared theta. So it's cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. And it equals 1 over cosine squared theta. So this is why we kind of need to know what things are. Some of these identities. Well, this right here is 1. This right here is sine over cosine is tangent, right? So this is tangent squared. And what's 1 over cosine? That's secant. Well, this is squared, so that's secant squared. There's your identity. 1 plus tangent squared theta equals secant squared theta. Okay? All right? Let's do it again, but now let's divide both sides by sine squared theta. Cosine squared plus sine squared equals 1. Let's divide both sides by sine squared. Here's my new fractions. This over sine squared theta, this over sine squared theta equals 1 over sine squared theta. So what's sine squared theta over sine squared theta is 1. This cosine over sine is cotangent, so that's cotangent squared. Okay, so it's kind of different order here, but that was our 1 plus cotangent squared theta equals cosecant squared theta. That's obviously 1 over sine is secant, that's cosecant squared. Okay, remember those, flipping the page back, there's those identities. Okay, so we just got them by dividing that original equation by either sine squared or cosine squared. All right. Now, let me go back here. Here's why we're gonna simplify some equations, or what they call verify some identities here, and basically you just need to know what to substitute. I want to show you. This is what we'll be doing on some worksheets, probably tomorrow, and definitely on an exam on Friday. You might see this again. Okay. Here's tangent theta cosecant theta, and I want you to prove to me that this whole thing equals secant theta. So let's just substitute. What's tangent theta? Sine theta over cosine theta, and this is multiplied by what's cosecant? 1 over sine theta, right? Well, the sine theta and the sine thetas are going to cancel, and what am I left with? 1 over cosine theta. Well, what's secant? That equals secant theta. Okay? So this is a simple case here, okay, of me just kind of simplifying and showing that this equals this. Here's a more elaborate one. Okay, here's tangent x plus cotangent x. I want you or me to prove to you that equals cosecant x secant x. All right. So I'll rewrite this as sine x over cosine x plus cotangents cosine x over sine x. Okay? I need a common denominator, so I got to multiply cosine by sine and sine by cosine. But remember, top and bottom, you have to multiply by 1. So I'll multiply this whole fraction by cosine x over cosine x. Multiply this whole fraction by this, okay, sine x over sine of x. Okay, so what's my common denominator? Sine times cosine, okay? So I'm going to have sine of x up top. What do I have? Sine, so I did top, this is my bottom, but I have to do the top too. Sine times sine is sine squared x over sine x cosine x plus, over here I have cosine squared x over sine x cosine x. Okay, cosine squared x over sine x cosine x. Okay. All right, I'll make this basically sine squared x plus sine squared x plus cosine squared x. And what's my denominator? I'm adding this and this, but this is what I'm adding over, right? It's all over sine x times cosine x, correct? Remember our identity? What's sine squared theta plus cosine squared theta? That equals what? 1, right? That's one of our first Pythagorean identity. 1 over sine x times cosine x in the denominator. Okay? All right. So what's 1 over sine? This is basically, remember, multiplication of fractions is numerator times numerator, denominator times denominator. This fraction is the same as 1 over sine x times 1 over cosine x, right? Well, what is that? 1 over sine is cosecant times what's that? That's 1 over cosine is secant, right? Erase that. Okay? All right, so I just broke that up to 1 over sine, 1 over cosine. That's cosecant times secant equals, what do we want to prove again? Cosecant x, secant x. There you have it. Okay? 13 minutes. That's the type of things you might see tomorrow. For those of you smart enough to watch the video, have a good night.